Okay, today we discuss about some problems based on Dalton's law. So, as we know, what is Dalton's law? So, it is the pressure exerted by a mixture of gases is equal to the sum of its partial pressures or sum of pressures of all individual gases. So, based on this, we do some problems. Okay, so let's see the first problem. So, given that equal masses of sulfur dioxide and oxygen are kept in a vessel at 27 degrees Celsius. The total pressure of the mixture is 2.1 atmosphere. So, find the partial pressure of SO2. So here the mass is not given particularly. So here మనకి separate masses ఇవ్వలేదు. Just it is given that the masses of SO2 and O2 are equal. They kept in the vessel 27 degrees Celsius. So the total pressure is 2.1 atmosphere. So find the partial pressure. So we have a relation, that is a partial pressure of any gas equals partial pressure of a gas equals mole fraction of that gas into total pressure. So this is the formula. Okay, here we need to find out the pressure of partial pressure of SO2. Means we need to find mole fraction of SO2 into P total. Say it is equation 1. Because we know P total is how much? 2.1 atmosphere. But what is X SO2? We don't know. First we calculate is X SO2. Then we substitute in equation 1. Okay. So what is mole fraction? So we do separately here, then we substitute the value here. The mole fraction of SO2 means its number of moles by total number of moles. Okay, so mole fraction of SO2 equal its number of moles. Number of moles, what is the formula? Weight by molecular weight. So what is the weight? There is no particular weight is given, but both are having equal masses. Just we are taking the mass X for both. So weight by, what is molecular weight? 64. Again same. What is O2 molecular weight? Weight is equal for both gases. How much will get? Again taking the LCM 64, this is X plus 2X. So on cancellation we will get X by 3X. That becomes 1 by 3. Means no need to calculate that 1 by 3 again. Here X are get cancelled. So just substitute that 1 by 3 here. So therefore PSO2 is equal to XSO2, how much you got? 1 by 3. So what is the total pressure is given? 2.1. So it gives exactly 0.7 atmosphere pressure. Okay, so take down. Okay, now we see the second problem. Let's see the second problem. Here it is given that a gas mixture contains nitrogen and helium in 7:4 ratio. In 7:4 ratio by weight. Made their masses ratio is 7:4. And given that the pressure of the total mixture is 760 mm. So we need to find the partial pressure of nitrogen. Find the partial pressure of nitrogen. Same formula. So, but the difference is to calculate the mole fraction part is different. So, akkada same grams ichchadu manaki ikkada, but here it is given 7:4. So, some calculation difference. So P gas equal X gas, mole fraction of the gas, P total, general formula. So if A gas find out chali, we need to find out partial pressure of nitrogen. Means mole fraction of nitrogen into P total. Say it is equation 1. Now the thing to calculate the mole fraction of nitrogen. Okay. So mole fraction of nitrogen is equal to number of moles of nitrogen by number of moles of nitrogen plus number of moles of helium. This is given how many grams. There is no particular grams are given. It is given in terms of ratio. So manaku final telvas kuda ratio kabatti this take it as 7 grams. 7 by its molecular weight how much? 28 by 7 by 28 plus, and here weight 4, its molecular weight 4. How much you will get? By so this cancel them. Here you will get how much? 1 by 4, 5 by 4. So on the cancellation, what we will get? The 4 get cancelled. It becomes 1 by 5. So therefore, very simply we can write 1 by 5. Now substitute that 1 by 5 here. What is the P total? That is 760. P total 76, the mole fraction is obtained here 5. So the finally we will get how much? Just on calculation we will get so here we will get 152 given in terms of mm. So mm. So in sometimes it may be asked in terms of atmosphere. So then we need to convert it into atmosphere. Or centimeters, we need to convert it to centimeters. Okay. So for example, if here we want to get converted into atmosphere. So how many? 760. Here we will get approximately 0.2 atmospheres. Okay. Here the units are very important. Now we see the next problem. At atmospheric pressure, a liter vessel contains a mixture of helium, and nitrogen, and given that if partial pressure of N2 is 500 mm, find partial pressure of helium. So here the simple one. So that is the partial pressure of first gas, that is nitrogen, is given. See, at atmosphere, important one, atmospheric pressure. So what do you mean by atmospheric pressure? So atmospheric pressure means the P total is 1 atmosphere, but it is given in terms of mm. So that is equal to 760 mm. Okay, 760 mm. In 1 atmosphere they done the experiment. So therefore P total equal, we can write simply according to Dalton's law, Pn2 is equal to, P total is equal to Pn2 plus P helium. So the total pressure is 760, Pn2 500 mm. So what about P helium? So therefore here we get P helium is equal to 760 minus 500, that is 26 millimeter. So just convert it into atmosphere. So there is no need, but in problems, in sometime multiple question answers, the option will be in other units. So how to convert the millimeters into atmosphere? Just made by this. Okay. So this is so 26 by 76, we will get how much? It is 26 divided 76. Here we will get 0.342 atmosphere. Okay, here the main thing is atmospheric pressure, that is 760 mm. We need to take that value. Let's see the another problem. If 1000 milliliter of a gas of a gas A, it's present at 600 torr. A is present at 600 torr. Torr means one of the smallest unit for pressure, torr, and 500 milliliter of another gas B is present at 600 torr, and they are mixed. They are mixed in a 2-liter flask. Mixed in a 2-liter flask. Find the total pressure. Means we need to find the P total. So we know what is the solution for it. Now we write it. So what is the P total pressure? Always the sum of individual gases, individual pressures, pressure of A and pressure of B. Okay, so we need to find out this PT is equal how much. So first we calculate the PA. Okay, calculation of PA. Okay, so here the important is about at first gas A present at what conditions. 600 torr pressure, 1000 milliliter means for PA starting P1 equal how much? 600 torr. Okay, so what is its volume at the time? 1000 milliliter. So then it is mixed. The mix cheste automatically the volume avutadi 1000 milliliter ikkada 500 1500 avvali. But both are mixed in a 2-liter vessel. And ఇక్కడ 1000 ml ఉన్న గ్యాస్ ని ఎక్కడ పంపించడం మనం they passed into another vessel which is having 2 liters. 2 liters means 200 milliliters. So what is its pressure in it? మనం ఫైండ్ అవుట్ చేయాల్సిన ఫైనల్ ప్రెషర్ అంటే సో ఫైనల్ ప్రెషర్ దేంట్లో ఉంటుంది 2 liters vessel లో ఉంటుంది అంటే 2 liter vessel లో pressure మనం we need to find out. So now according to Boyle's law, so what is the relation? So the P1 V1 equals P2 V2. So P1 how much? 600, 1000 equals, find the P2. So V2 2000. So finally you got how much? So here too we get 300 torr. Means here P2 means this is the pressure of PA. And PA pressure at 200 milliliters flow pressure of a gas is 300 torr. So ఇది మనం Same for second gas calculated now. Calculation of pressure of B. So what is the initial condition for B gas? 600 tar. What is its value at the time? So it is also transferred to 2 liters. Okay, so here we will get how much? 600 tar, this is 500. Okay, what is the P2? So there is 2000 milliliters. Okay, and here we will get how much finally? 1500 tar, 30. Okay, so I think this is what is this value? 600. So okay. So finally we get how much P2 is equal to, that is equal to 150 tar. Means the pressure of A is 300, the pressure of B is 150. So finally we got how much? Substitute in equation 1. So 1 implies P total equal pressure of A, that is 300. What is pressure of B? 150. Okay. That is 450 tar. So this is the final pressure. Okay. Now we see the next problem. A gas mixture contains two moles of A, 3 moles of B. Three moles of B and 5 moles of C. And 10 moles of D. And given that if the partial pressure of C is 1.5 atmospheres, find the total pressure. Okay, so here, so it is given that all number of moles of different all number of moles of different gases, and partial pressure of a single gas is given. But we need to find the total pressure. Okay, so what is the, how to write the total pressure? The total pressure we can write pressure of A, pressure of B, pressure of C, and pressure of D. Okay, so just say it is equation 1. So it is given only for partial pressure of C is only given. Okay, so partial pressure of C is given. We need to find out the total pressure. So maybe with the help of that, with the help of this clue, we may calculate it. Okay, so this is one process, and with the help of this clue, okay, we know the partial pressure of a gas equals mole fraction of that gas into P total. So using this it becomes simple. Okay, so P gas we know that means here we are taking the partial pressure of C is given, partial pressure of C equals mole fraction of C into T. Okay, don't need this. This is the common formula. Okay, so what is the PC? We know that is 1.5. PT we need to find out 1.5 atm. So PT we need to find. So XC could find out here. So when the XC find, we are able to find the XC. Means mole fraction of XC find out this, the PT find out change. So how to find this XC? Means mole fraction of C equals number of moles of C by number of moles of A, number of moles of B, number of moles of C, number of moles of D. So this is general formula. We know that mole fraction of any component is equal to ratio of its number of moles, ratio of its number of moles by total number of moles. Mole fraction of any gas equal to its number of moles by number of moles of all gases. What is the number of moles of C here? 5 moles by, what is the A? B how much? 3. 5. D how much? 10. So how much you will get? 15. Right, 1. That is 5 by 10 means so just write it as 1 by 4. Right? Again we are going to calculate here. Now substitute in equation 1. Okay, PC equal how much? 1.5. XC already you calculated, that is 1 by 4 into P total. Therefore P total is equal to how much? 1.5 into 4. So how much you will get here? 1.5 into 4 means 336. Here the total pressure is 6 atmosphere. Okay. Okay, see the last one. So a gaseous mixture of 3 gases. A mixture of 3 gases A, B and C has a pressure of 10 atms, 10 atmospheres. The total number of moles given the total number of moles of all the gases is 10. Given that if the partial pressures of A comma B are 3 and 1 atmospheres, 3 and 1 atmospheres respectively, and the molecular weight of C is given as just 2. Here we need to find the weight of C. Find the weight of C in grams. So generally in all these calculations we will get the weight in terms of grams only. Okay. So now we see this. Okay, see. Here the mixture of 3 gases A, B, C are having the total pressure 10 atmosphere. Means it is given that P total is equal to 10 atmospheres. The total number of moles means number of moles of A, number of moles of B, number of moles of C is given as 10 moles. If the partial pressure of A and B, it is also given. Okay, so writing here partial pressure of A 3 atms and partial pressure of B 1 atms, and it is given that molecular weight of C is equal to 2. We need to find the weight of C. Okay, so these are the conditions and this is the question. So weight of C means so these are the given values. Now we need to identify which formula is useful. Okay, see, with the help of these 3 values, so we know that P total is equal to Dalton's law, PA plus PB plus PC. So it is given that 10 equals 3 plus 1 plus PC. And here we get what is the PC? What is the partial pressure of C now? 6 atmospheres. And partial pressure, total pressure, we have a relation. Partial pressure of C is equals mole fraction of C into total pressure. Okay, now you got that partial pressure 6. XC means number of moles of C by number of moles of A, number of moles of B, number of moles of C into P total. So how much? What is PT? 10. And so this value is also given. So what is the total number of moles? That is given as 10. Okay, substitute that here. So now the NC is equal to how much? Becomes so no need to here directly there is a cancellation takes place. So 6 equals NC by 10 is total pressure 10. So thus they will get cancelled. So what is the number of moles? Number of moles of C is equal to how much? C. Number of moles means what is the formula? Weight by molecular weight equals 6. What is the molecular weight is given? 2 grams. 2. What is the weight? Simple. Therefore, weight equals 6 into 2, that is 12 grams. Okay, here there is two formulas. So there is a P total pressure is given. So Dalton's law, first law, and next this is again Dalton's law. Okay, just take down.